Have you ever seen those incredibly realistic AI images or even videos now
hmm
and just thought, how? How does it make that from, well, seemingly nothing? Today, we're doing a deep dive into exactly that. We're looking at diffusion models. Our mission really is to get past the buzzwords and unpack how they actually work. You know, this whole idea of denoising.
Yeah, understanding this is becoming pretty crucial. It's not just hype. The way these models create things is fundamentally different, and that's why we're seeing such a huge leap in the quality and variety of what AI can generate. It's hitting fields from art to, well, filmmaking already.
Okay, let's really get into this because honestly, when I first heard the concept, it felt totally backwards. Like normally you start with a blank page, right, and build up. But diffusion models, they flip that completely. They start with pure chaos, visual static, just noise. And then they work backwards, cleaning it up, refining it step by step until something coherent emerges. An image, audio, even video.
That's spot on. It really begins with the training phase.
hmm
You feed the model a real image, a clean one. Then noise, think like old TV static, Gaussian noise usually gets added. But crucially, it's added gradually, little by little, over, maybe hundreds, sometimes even 1,000 steps, until that original clear image, it's just gone. It looks like pure random noise. And the whole point of this training is for the model to learn precisely how to reverse that. It has to figure out exactly how much noise was added at every single step.
Right, so it learns to undo the mess, basically.
Exactly. It's learning the path back from noise to clarity.
Okay, so if training is about learning to undo noise, how does that let it make something totally new? Where's the creation?
Ah, that's the clever part. That's the generation phase. Once the model's trained, if you want it to create something novel, you just give it, well, a fresh screen of pure random noise. And then it uses everything it learned during training to slowly, carefully, step by step, remove that noise. It's like it's sculpting, pulling order out of that initial randomness. And because it learned the whole noise to data process, not just specific examples, it can generate really diverse and high fidelity results, way beyond what older models could often manage.
Okay, that clicks now. It's kind of like imagine teaching a computer how to perfectly unblur a really fuzzy photo. But you start with the blur itself, and the computer knows exactly the steps needed to bring the sharp image back out.
Precisely. It's like running the blurring process in reverse.
And that careful step-by-step refinement, even though it takes a lot of computation, that's why the results are so detailed and realistic. It's not just guessing.
Right. It's calculating the path back to coherence, often using complex networks like UNets that are good at seeing patterns in that noisy data.
And this whole denoising idea, pulling order from chaos, that's the engine behind some of the big names you've probably encountered. We're talking DALL-E 2, DALL-E 3, Google's Imagen, Stable Diffusion, all those amazing text-to-image tools.
Yep.
And even Sora, OpenAI's video generator, it uses similar diffusion principles to make those mind-blowing video clips just from text.
Indeed. So the surprising power, this sort of magic of diffusion models, really boils down to this elegant trick, turning noise into reality. They don't create from nothing. They refine. They uncover structure from randomness.
Which, when you think about it, raises a really interesting question, doesn't it? If these AIs create by denoising patterns that are sort of already latent in the noise, what does that actually say about AI creativity? Is it finding something that was always potentially there? Does it mean creativity isn't always about a blank slate, but maybe about finding order in the chaos, whether that's digital noise or, even the jumble of ideas in our own heads?
Yeah.
Something to think about.